So this is your frame design preferences. So in this, what are the main things? Okay, so in this, what are the main things? First is your code. So code should be IS 456 2000, and your multi-response case. So this will be step by step all. So by default, software will give this results only. Okay, then your number of interaction curves and points, by default it will be 24 and 11, and minimum eccentricity. So minimum eccentricity you need to consider for your design. Then additional moment, that is also yes, you need to consider the additional moments. Then P delta, so P delta will be also yes. Then B by C capacity ratio, if your building is in zone 3, 4 and 5, then you will be using the B by C capacity ratio as yes. Then after that, this ignore beneficial PU. Okay, so this you can see later. Then factor of safety for the steel and concrete, so that is 1.15, and for the concrete it is 1.5. okay. Now after that, we have seen the interaction drawing, then interaction curves, interaction points, then minimum eccentricity, and the basic design we have seen. So now we will go in depth about the calculation. So just open the tabs, just run the model. Okay, so after running the analysis, I will just go to design, concrete frame design, and just start the design. So before that, you need to check all the preferences and the overrides. So once the design is done, just go to concrete frame design and verify all members. So you can see the 52 members are failing. Okay, so this later we will see. Now we will take one column and we will study about that. I will just off all the other things, beams, floors and walls. Just take any column and right click it. So you will have the interaction details and overrides. So if you go into the interaction, what is the main thing? So you can see on which moment it is governing. Let's suppose if you go to the MM, you can see this column is governed by the M2 moment, whereas this column is not governed by the M3 moment. Okay, but still it is passing. So just right click, go to details. Now in this we will see the flexural details. So in the flexural details, so first these are your basic thing, basic sizes and other things, basic column details, what is the section size, material properties and other things. Then what is the main thing in this? You can see this is the critical one. So that column has been designed for axial load of 63.84 kilonewton and M2 moment of 78 kilonewton meter and M3 moment of 6.6 kilonewton meter. So this is the overall moment for which this column has been designed. Now after that, you are having the minimum moments. So what is the minimum moment formula? That is your L by 500 plus D by 30, or L by 500 plus B by 30. So if you just calculate it, you will get these values. Okay, so this is your minimum amount in this direction and minimum amount in the other direction. Okay, now we will just go down. Okay, so you can see in this example also. Okay, so in this sum, this is the calculation. So in this document you can find this is the column. So in this column it has been designed for this axial load and these two moments. Okay, so and this will be your minimum moment. So how this 5.72 is getting calculated? Based upon this formula. So you can go down, you can see here. Okay, L by 500 plus D by 30, and the other direction you need to find. So what is the E value that you are giving? E value that you are getting is 21 mm. Okay, so at least what is the E minimum value? So as per code, what is the E minimum value in X direction and Y direction? 20 mm. Okay, so if the eccentricity value from this formula is coming less than 20 mm, still you need to consider 20 mm of eccentricity and you need to design it. Okay, so this E minimum value should be greater than or equal to 20 mm. Okay, so that means whatever based on the formula you are calculating, if that value is coming less than 20, still you need to take 20 mm. If it is coming more than 20 mm, you can directly take whatever value is coming. Okay, so now you got the E minimum value. So what is the E minimum value? With that E minimum value, you need to multiply the axial load. So what is the axial load? What is the axial load of this column? Axial load is 272 kilonewton. So you can see this 272 kilonewton into this eccentricity will give you the minimum moments. Okay, so this is your minimum moments. Similarly, these minimum moments will be in one direction as well as in the other direction also, in the X direction as well as in the other direction also. So any doubt how to calculate the minimum moments? Yes, now you can ask.
So for design, still it will no consider the M2 moment, no, that without a minimum is very less. So for design, we will consider the
No, see, the ultimate load. So the ultimate load and this thing moment. So the maximum is this one only. The column has been designed for these two moments and this axial load only, but these are some checks. Okay, so let's suppose in the M2 side your moment is 1 only, 1.7 only. Then in that case what will happen? This moment will go here.
we'll consider this moment. Okay.
So these are the ultimate one. So based on this you need to check some design things. So what are those things? That is your first is your minimum moment, and after that slenderness moments, additional moments, many other moments will come. So now we have seen only the minimum moment. Okay, now after that, okay, so this is your minimum moments. Then after that you are having biaxial moments, sway and non-sway moments. Okay, so sway and non-sway moments. So sway and non-sway. So before entering into this sway and non-sway moments, you need to go into the Q factor. So Q factor is your global stability index. Just go to the Q factor calculation. Go into this example. Yes, so you can see this one. Okay, so now focus only on this effective length factor. Okay, so now the effective length factor for the sway and for the non-sway it is like that. So what is sway means? This is your frame and this is swaying more. Okay, so now you need to understand. So this is what yesterday we have seen. What is the K value for this? It is 0.65. Okay, so this K equal to 0.65 will be applicable only when if it is a non-sway. Okay, so swaying. So swaying means what? What does it mean? So this is your lateral force whenever this lateral force is coming, this building will sway something like this. Correct, your building is going to sway like this. So during that sway, will this same concept will come? Because of this sway, let's suppose if you are taking this can become like this also. This is your fixed and this is your fixed. Okay, so if the frame is non-sway, then your K value will be this one. If the frame is swaying, then what will happen? Actually, this K value will not come. It will go more than that. Because due to the lateral force, your frame is swaying. So this bending moment also is going to be more. Okay, so what will happen? This is, okay, what we will do, I'll just delete it again. Okay, equal to 0.65. So this is for your non-sway. Let's suppose same thing is happening and due to the lateral force, this is swaying. So what will happen? This itself, it can become like this.
From it itself, we'll have.
Yes, this shape will change to here because of the swaying of the frame. Then in that case, what will happen? K will not be 0.5. K can go 1, 2, 3, 4, some other value, some value. Okay, so what you need to understand, the K value, the effective length factor will be different for non-sway as well as sway. Okay, so the K value is going to be different for your sway as well as non-sway. Now, how you can decide whether that particular point or that particular frame is in sway or non-sway? So how you can classify that? So for classifying that, you need to find the Q index. Q index, that is your Q is also called as your global stability index. Global stability index. Okay, so now we will come here. So you can see here. So in this you can see K value for the sway. Sway is how much? 1.5. Now you cannot ask me how to calculate this 1.4 because based upon how much sway is happening, the software will actually calculate it. In manually you cannot calculate. In manually you can calculate only this only. K non-sway is how much? It will be in the range 0.65. See, the code is saying as per code the theoretical value is 0.5, but the recommended value is 0.65. But in ETABS you will not get this 0.65. This is some round off value. It might be slightly less or more than that. So that is what you can see here. So ETABS, this is your actual value. Okay, so whatever this 0.65 is there, that will not be 100% correct. But whatever this ETABS is giving, this will be your actual condition. Okay, so now K value is in the range of 0.65. So that is fine. Now for the K in the sway value, it is more than that. It is more than 0.65, 1.4 and 2. But yesterday I have said that at any case, your maximum K value cannot be greater than 1. Okay, this condition is also there. Okay, fine. Now how to classify this sway or non-sway based upon your Q factor. So you can see the Q factor here. Okay, so how to calculate the Q factor? So for calculating Q factor, there is some formula is there. So I will show you in the last. But generally, what is the main condition? If this Q value is greater than 0.04, then that is called as sway. And if the Q value is less than 0.04, then it is called as non-sway. Okay, so here you can see. So for the first one, what is the K factor? Q value, it is 0.01. So it is less than 0.04. So this is in the major direction. It is non-sway. But in the minor direction, you can see the value is more than 0.004. So in the minor direction, it is sway. That means in the minor direction, your column is swaying more. In the major direction, the sway is not that much. Okay. Then ultimately you need to focus on these two only. K used, what is the K value that is used for your design? So this is your non-sway, so directly you can take this value. This value will come here. But the second, in the other direction, it is sway. That means this value should come. K value equal to 2 should come. But this value will not come because the maximum K value itself is 1 only. So this value will come here as 1. Any doubt in this? Yes, any doubt in this way, non-sway, you?
So can you differentiate bending and sway?
What is it?
Can you differentiate between bending and sway?
Bending and?
Sway. What is sway and what is bending?
No, see. Let's suppose this is your frame. Okay, so in the frame, if it is not swaying also, you will be having bending moment like this. Correct, you will be having the bending moment like this. This frame is not swaying. Let's suppose lateral force is coming. Then what will happen? This frame will not be like this.
Reflection.
This is going to this is going to deform like this. Now in that case, now the frame is itself is swaying. Now in that case, will this bending will be same? It might increase also, it might become like this also. This can go like this also. Correct, your bending shape will change. Now you just check this shape. Now this shape, if it is a fixed and fixed, then K is equal to 0.65. But now the shape is also changed. Now how to calculate, how they are calculating? So there will be one point. Okay, so there will be one point. Then based on that, how it is, rotation is there. Based upon that, you need to find this K value. Okay, so no need to go into this. So based upon this profile, they have arrived K is equal to 0.65, K is equal to 1, K equal to 2, like that in the code. Okay, so just you need to understand only one concept. The K value will be different for your non-sway and K value will be different for your sway frames, because there is a lateral displacement, so your bending drawing also is going to be changed. So based on that, your K value will change. Now in that, what is the maximum thing, what is the upper limit? So at any case, your K value cannot be greater than 1. K value not greater than 1. So at any case, your K value cannot be greater than 1. So that you can see here. Okay, so first in the major direction it is sway, but in the major direction it is non-sway. In the minor direction it is sway. But in the major direction we have used this value. The minor direction, even though if it is sway also, actually you need to use this value. But what is the maximum upper limit? It is 1 only. Okay, so this will automatically become 1. Okay, so this is your effective length factor and Q value and K values. Any doubt in this?
So actually,
Why it can't be more than one,
Q
sir?
is come. Q for
Yes, what is it?
bending is for beam and sway is for column, no, sir?
No, see, bending is different, sway is sway means it is just
Deform
it is
for column.
it is displacing, that is sway.
That is,
Bending means bending will be there, bending is different,
bending will be-
sway is different. Yes, any doubt in only this sway? What is sway, non-sway? See, non-sway you cannot calculate. Okay, non-sway you cannot calculate. Based upon how much it is swaying, the K value the software will generate. Only the K for sway you cannot calculate. Only the K for non-sway you can calculate. Yes.
Sir,
for
why
consent.
we have put this upper limit on K? Like, why it can't be more than one?
Okay, so why the K value cannot be more than 1? So in your calculation, ultimately you are going to use, so let's suppose you are finding the ultimate capacity. In that you will not take the total length. Okay, you will always not take the total length of your column. So total length of your column into effective length, you will multiply. Total length into effective length you will put, and whatever this value is coming, let's suppose your 3000 is your column, so you will take 3000. Okay, so 3000 also you will not take, you will take only the unbraced length. So unbraced length is how much? 2.4 meter. Okay, so you will take the 2.4 meter only. Okay, so you will take the 2.4 meter into the K value. So let's suppose K value is 0.65, or you take the total length only, don't confuse, take the total length. So that is 3000. 3000 into your K value you will multiply. So K value, if you are 0.65, so how much we will get? 2300 something. So this is your total length for which the column will be designed. Okay, now you just consider the K value at any case, it can be 1 only. Actually inside the column is 3 meter only. So you can design this column up to, you can take the height of the column as 3 meter only. It cannot go more than 3 meter. Correct? It can go less than 3 meter because of the effective length factor. It can go less than 3 meter. But at any case, it cannot go more than 3 meter. Correct?
Yes, sir.
So that is what we are having the upper limit of the K as 1 only. Okay, so if K value is 1 means you are designing the column height of 3 meter. That is correct. But actually no need to design for 3 meter. It will be little less than that, 2.7 or 2.6 meter. Okay, so only you are having the K value as 1. So let's suppose K value here, you can see K value is 2. So you cannot use 2, because if you are using the value 2, then 3000 into 2 will give you 6 meter. 6 meter. So the actually the column height is 3 meter only. So how you can design that column for 6 meter? That is wrong. So only you are having the upper limit of K value of 1. No need to understand in depth. Don't go in depth. Don't go in depth. Just understand some small concepts. Okay. In reality, you are not going to go through each and everything. Just analyze what are the things that is happening, and if some members are failing, then you need to investigate, or else you will not investigate. Okay. So now we have completed the effective length factor. Okay, so after that you go into the additional moments. So if you want to study in depth, you can go to this class IS 25.2 and Annexure E. So in Annexure E they have given how to calculate the Q factor, what is the formula, those things are given in Annexure E. Okay, so now go to additional moments. So what is additional moments? So additional moments, you can take it as due to its shape. Okay, due to the shape of the column, you will have some additional moments. So that is your slenderness effect. Due to the slenderness effect, you will have some additional moments. Let's suppose this is your column, maybe 300 cross 2 meter, 300 cross 2000. So what will happen? This column will bend in this direction, correct? Because due to this shape effect itself, see, this column it cannot be straight. Why? Because in one dimension it is very less, and in the other dimension it is very huge. So this will bend. So this will have some additional moments. So that is what we are finding. So additional moments, how we are finding? Based upon this ratio, KL by depth. So what is the K? So K is your length factor. So what is the length factor here? So the software has taken 0.79. So what is this factor and this factor? So this factor will be your unbraced one. Okay, so this length factor K is your unbraced one. This K will be your unbraced one, and this will be your effective one. Okay. after that what you need to find this one. So this is the dimension in that direction. So 0.793 into L. So what is the L you have considered? L maybe you can take 2.9 meter divided by the D. So that this D will be 600. So if you put, you will get some ratio. So this also, it will be not the total length, it will be your unbraced length. Okay, not unbraced length. This will be your total length because you are already finding the factor. Okay, so KL by D. So this will be your unbraced factor, unbraced length factor. This will be your total length, total or effective length. Then this will be your dimension in that particular direction. So if you just put, you will get some ratio. Okay, so this ratio, the maximum upper limit is 12. If it is exceeding more than 12, then MA. So MA means your additional moments. Additional moments will be generated. Now in this you can see this ratio is not exceeding more than 12. So the additional moment will not be generated. It will be 0. Okay. So any doubt in this additional moment? So additional moments means it is due to the slenderness effect. Slenderness effect of your column size. Okay, yes. So now additional moment is over. So after that there is one more thing called additional moment reduction factor. So if you are finding the additional moment, then you can reduce the moment. So based on the formulas, there are some calculations also. Okay, now in our case the moment itself is 0. So the additional moment reduction factor, so that also K also will become 0. If there is some additional moments, then that moments can be reduced by some factor. Now in our case it is 0, so the additional moment reduction factor also will become 0. So where you can see here. You can see here, ultimately they have given here K into MA. So MA is your additional moment and K is your reduction, additional moment reduction factor. So MA is 0, so automatically the K also will become 0. So this minimum moment you already know, additional moment you know, additional moment reduction you know, and this is your minimum eccentricity. So I said no, if it is more than 20, that value will come. If it is less than 20, the 20 mm will come. Okay. Then after that, what is the thing? Initial moments. So again you are having one more new term called initial moments. So how you can find the initial moments? So in initial moments, you need to refer this code 13920. So in that what they are saying, at least 40% and 60%. So two cases are there, 40% and 60% of the moments you need to take as initial moments. I'll just show it in the example. Okay, so now in this, I think this is over, non-sway moments. Okay, so sway moments. So that portal frame is not swaying. So there is no sway moments. So can you calculate how much is the sway moments? In manually you cannot do. The software will automatically give you how much sway in that particular direction the software will automatically give. Okay, so if some sway moments are there, then what will happen? These two moments will be added. These two moments will be added and it will be taken here. Okay, so in our case the sway moments are 0 only. Okay, so just we will take the non-sway moments. So this 154 and 94, how we have got? So this moment is from the beam. So due to from the beam, in that column the moment is transferred, and this is the moment in the 3 direction and from the 2 direction. Okay. Okay, so you can see the initial moments. So let's suppose this is your end moment. So yesterday I already said, so let's suppose this is your column. So in column, this is your top. So in top, you just see, in top, the moment is how much? 154. But in the bottom, you can see it is 145. So always the top and bottom, it will be in the same range, but it will never be same. Okay, this is your M3 axis. Let's suppose in the other axis also, this is for top and this is for bottom. So which one you need to take? You need to take the critical one. You need to take the critical one, these two. Okay, so you will take only these two. Now, what is the initial moment? So initial moments means at least 40% you need to take. So that is as per this class 39.7 IS 456 2000. At least 40% of the moment you need to take, and for these two moments the column has to be designed. That is the, it is not designed, just you are checking. Okay, so this is your initial moments. So you can see initial moments are calculated here and here. Then after that, you know the additional moment and additional moment reduction, so that is also 0. Then you are having the minimum moments, so minimum moments also you know. So now these are like your option. So this is your option A, so this is your option B, your option C. Okay, this is C and this is D. So which option you will design? You will be designed for the critical one. You will be taking the critical one. So let's suppose this A is having more value. A is having M3 is how much? 154, and M2 is how much? 94. So you will take these two values and you will design that column. That is what it is given. You can see here also. What is the ultimate design moment? It is 154 and 94. Then what is the use of these moments? So these are the conditions. You need to check for the conditions. First thing, you check for the minimum moment. So minimum moment check is over. Then once minimum moment check is over, then you can calculate the initial moments. So initial moments means end moments into 40%. So this is your second check. Then after that, you will find the effective length factor. So based on that effective length factor, you need to create the additional moments. So additional moment is based upon your slenderness effect. So additional moments will be generated, and based upon this, reduction will happen. Okay, so these are various checks. So I'll just note down. So in first one will be your end moments. Next one is end moments. So end moments means your column moments. So end moments will come from your beams. Okay, then next is your initial moments. Initial moments, what is the formula? 40% 0.4 into end moment. So in some cases you need to take 60% also. So you need to refer the class. Then you are having minimum moment. Then you are having additional moments. Additional moments plus its reduction. These are the 4 types of moments. So out of these 4 types, whichever moment is critical, you will take and you will design it. So the software will automatically design. So any doubt in these 4? Yes. No need to go in depth about this. Just you need to understand there are some things like initial moment, minimum moment, additional moment. That's all.
So additional moment is happening because of column.
Additional moment is based upon your slenderness effect. Additional moment will be generated based upon your slenderness effect. So minimum moment based upon the criteria, 20 mm minimum eccentricity. Based on that, minimum moment will come. Initial moment also again based upon the code, 40% of the end moment you need to take. So end moment, where it will come, end moment will come from the beam. So out of these four, whichever is maximum, the software will automatically take and it will design that particular axis. So you are having 2 axis and 3 axis. So that yesterday we have seen. So now we will go into this. So I think we have covered the slenderness effect, effective length factor, additional moment reduction, and additional moments. Okay, so your flexural design is over. So any doubt in the flexural design? Generally, if you are designing, just go to envelope. After that, go here, take the percentage. So what is the maximum percentage? Maximum percentage is 1.9 percentage. Directly detail it. That's all. That is the procedure. Let's suppose this is failing. Here your demand is 5 percentage. Now in that case, what you need to do? You need to reduce this. So how you can reduce? You need to go into the flexural details and you need to investigate that column is governing by M2 moment or M3 moment. That you will do with the help of interaction drawing. Then after that, is it slender or not? Is that column slender or not? So that you need to investigate. Then if some additional moment is generating or not. So all those parameters you need to investigate one by one. Okay, yes. So any doubt in the flexural details? No need to study all these things. No need to study the formula and other things. Interview they will not ask. Just they will ask, do you know what is slenderness ratio? Why it is important in your column design? That time you need to say, if that ratio is exceeding more than 12, it will create some additional moments. So that will create some moments in your column design. So likewise you need to say. Then they will ask about the sway factors. Okay, they will ask the K values and other things. Okay. Yes, so now we will go into the shear. So shear is comparatively easy. So just first we will see in the envelope. So if in the envelope, if you want to see the shear, so just you need to go here. So shear force for the major as well as minor. So what we need to do, just take the maximum one. This is just 665 mm square. So just take this 665 mm square, convert this into bar and spacing, and you just detail it. That's all. Okay, so now we will go into the shear details. Shear details, okay. So in shear details also you can see what is the thing. This you already know, that is your additional moment reduction factor. So this additional moment also you already know. Okay, and there are many calculations. So no need to go into the calculation. Just what is the main thing you need to see? You can see only this one, shear. Okay, so just you can see only this one, shear rebar design. So in the V2 side, what is the shear force? Shear force is 51 kilonewton, and in the V3 side the shear force is 53 kilonewton. Then due to this shear force, what is the stress, shear stress? So what is the formula? T equal to VU by B into D. You just substitute this shear force here and B and D, you will get the shear stress. Okay, then in that, what is the, okay, so this is T, tau. So in this concrete you are having tau CD. So that means the concrete itself can take this much shear stress, 0.7 and 0.75 in that two particular directions. So this is 0 Newton per mm square and Newton per mm square. We'll just write down here. So V is the shear force. Then tau is the shear stress due to shear force. So what is the formula? Tau is equal to VU by B into D. Now what is tau CD? So tau CD means it is the shear capacity of concrete without any shear reinforcements. Okay, so is the shear capacity of the concrete without any shear reinforcements. Then what is the next thing? Next you are having tau C max. So this will be your maximum shear capacity of concrete with shear rebar. Okay. Yeah, can I delete? Can I delete it? Can I delete it?
Yes.
Yes, sir.
Okay, so now we will see into that column. Take any column, right click, details and shear details, and just go to the last. So in the last version you are having the same thing. So what is this? This is your shear force, and this is the shear stress due to this shear force, and this is the shear capacity of that concrete without any shear rebar, and this is the maximum shear stress, maximum shear capacity of the concrete with shear rebar. Now you can see without any shear rebar itself the column is okay, because the stress is very less. If the stress is more than this value, then only actually you need to provide the shear rebar. Okay, but you can see in this the shear is very less, so there is no need for the shear reinforcements. So now as per your design, no need for shear rebar, no need for shear rebar, but as per the site you need to provide as per the site and as per the code. So in code you are having minimum shear rebar spacing, minimum shear rebar spacing, and as per the site also you need to have the shear rebars, that is your links. Then only you can keep all the vertical rebars in one place. Okay, so if you see as per the site you need to provide the shear rebar, and if you see as per the code you need to provide some shear rebar as per some formulas. So 3-4 conditions are there, based upon that you need to provide the shear rebar. But if you see as per design, it is not needed. So always all the three, design aspect, code and site, it should satisfy. So what we will do, we will go with the code aspect. So we will go with the formula, we will find the minimum shear requirement and we will provide it. So that also ETABS has already done. You can see here ETABS has already provided the minimum shear rebar, so that is 665 mm square per meter. So this one directly you need to provide it. Okay, so let's suppose if it is failing, let's suppose if this value, if this stress value is exceeding more than 3.51, then it will fail. Here it will show as overstressed. So that means at any cost your concrete cannot take more than 3.5 Newton per mm square. We are providing with shear rebar, without shear rebar, that does not matter. At any case your shear stress cannot go more than this value. So in that case you can increase your grade of concrete, so maybe up to M40 and above your maximum shear stress value is 4 Newton per mm square. So you can increase your grade and you can make it pass. Okay, so in the shear, what is the main thing? Just you need to see only this table, that's all. And whatever it is showing, you just take it and detail it. So how to convert this, those things you will see in the detailing part. Okay, so any doubt in the shear? So if you go to the envelope also, you will get the same thing. You just go to envelope and go to the shear. Directly you will get this only. Just take this value 665 mm square and provide it, that's all. Any doubt in the shear? Yes, any doubt? Do you have any doubt in the shear?
Yeah, if it is exceed 3.5, sir, what we want to increase the grade of concrete.
Yes, if it is exceeding 3.5, you need to increase the grade of concrete. Yes, you can increase the area. See, the formula is this. Okay, tau v equal to vu by b into d. So if that is exceeding, just go to that sheet. Okay, so in this, first thing you are having two options. One is you can decrease this. You can decrease this stress. How you can decrease? If you want to decrease tau v, then you need to increase either breadth or depth. If you increase breadth or depth, then automatically this tau v will decrease. So that is one option. So you can decrease this. So you can decrease this by increasing either breadth or depth. Then what is the next thing? You can increase tau c max. So how you can increase? By increasing the grade of concrete. So that also you can do up to certain limit only. So M40. For M40 and above, the maximum tau c max is 4 only. So you cannot go more than 4 also. So in that case, what you will do? You need to increase your breadth and depth only. Is it clear? Okay, so now we will go into this one. So up to this we have seen only the normal design. So normal design or your ordinary design, it is going to be following the same procedure. Normal and ordinary design, this is the same calculations and other things. Let's suppose now you are going into the ductile design. So ductile design. So in ductile design, there are some differences. First, related to your design as well as related to your detailing. What are those differences? You can see. Close it. So we will see in the documentation. It is there. Yeah, it is here. Yes. So this is the document we have taken from the concrete frame design. So in this you can see this one. So this is your ordinary non-sway moments. So that means you are just normally designing the column or beam. Then what does this means? This is your ductile. So you are going to design for ductility. Okay, so in that you can find the formulas. So for column, the combination, so load combinations will be everything, but the minimum percentage for your beams will differ. Okay, so there is some difference in your rebar percentage in your beams only. Okay, so for column it is not there. So for columns, what is the difference? Just you need to check the column capacity shear. So for the beams, whenever we are seeing the beams, that time we will see this. Okay, now how you can detail a column in ductile? How you can design a column in ductile? So if you are designing the column for ductile, then first one you need to consider this beam column capacity ratio. Beam column capacity ratio. So you need to design that column and beam with this option, beam column capacity ratio. So what is the general idea about this? So it is to make your columns stronger and beams weaker. So why you are doing this beam column capacity ratio? Because your column should be strong and your beams should be weak. So why it is like that? If some failure is happening in your building, your beam can fail. If some beam is failing, then it is a local failure. But if some column is failing, it is a global failure. Your building will collapse. But if one beam is failing, your building will not collapse. Okay, so where it is given in code, so we go to that. Okay, yes. So this is your B by C capacity ratio. So this is given in which code? It is given in 13920. 13920 is for your ductile detailing code, ductile design and detailing. Okay, yes. So just we will go down. Okay, so in this what they have said. So now we are taking only this joint. You are taking only this joint. Okay, now in that joint you are going to find what is the capacity. Okay, so now in this joint there are beams also as well as columns. So there are two columns. So one is your column at the top and column at the bottom. So these are your two columns. Then you will have the beams. So beams on the left side, beams on the right side, and maybe in the other two directions also you will have. So maximum how much beam you can have? You can have 4 beams, and maximum how many columns you can have? 2 columns. Okay, so in this what is the condition? The summation of moment capacity of your column should be at least greater than or equal to 1.4 times the summation of capacity of the moment capacity of the beams. So just give example. So this beam moment capacity is 50, and this beam moment carrying capacity is 50, and this column capacity is 100, this column capacity is 100. Now what you need to do, just you need to add all the columns and all the beams. 100 plus 100 should be greater than equal to 1.4 times 50 plus 50. So how much you will get? 100, 140, here 200. Now this condition is satisfied. Correct? Is this clear? Is this example?
Yes.
Yes, again I will repeat. So what we are doing, we are just finding the capacity of this column and this column. So column at the top level, the capacity is 100. So 100 kilonewton meter. It is your bedding capacity. Then for the column below also it is 100. Then for this beam maybe 50, and this beam it is 50. So now what you need to just add all the columns and equate with the beams. So 100 plus 100, it should be greater than or equal to 1.4 into your beam. So one beam is 50 and another beam is 50. So how much you will get? 200. That should be greater than 100. 100 into 1.4, it is 140. So now this condition is satisfied. So that means what? Ultimately what you are saying, you are at this joint. Ultimately you are checking for this joint only. At this joint your column is stronger, your beams is weaker. So how much? It is more than 40%. Your column is more than 40% stronger than your beam. Any doubt in this? Yes, online students, any doubt?
What if it is less than 1.4?
Yeah, I will come.
So how to find this moment, the column capacity?
Moment of the column, the software will give you. See, this is the example. Just delete. Just close it. Go to tabs. Right click details. So in this you are having this option BCCR. So that is beam column capacity ratio. Just click on details and here again you will find. So this ratio you already know. You can see. See, these are some detailed calculations. I am not going into too much depth. If I go, then you will forget. See, column above and column below. What is the capacity?
Okay, capacity.
It will calculate. Then you are having two beams. So what is the capacity of the beam in the positive as well as in the negative? So it will calculate and ultimately it will, you need to find the ratio only. The software will give this ratio. This
So that
ratio.
233 is the total capacity of the column. That you can, the column can carry that 233 kilonewton per meter.
Yes,
That is
yes,
what
yes,
it's.
yes, yes. Okay, so don't see these ratios. Okay, so these ratios, it is for 1. You see these ratios are for 1. That means your column should be strong, it should be less than 1. It is like that. Okay, don't see these ratios. Yeah, you can see this directly. Only you refer this one. Just refer only this box. So you are having two sides, major and minor. So in the major, your column is stronger. Okay, it is how much? 65%. It is stronger. In the minor side, it is how much? It is 2%. 2% stronger. So 2% means 2% after this 40. So actually it is 42% here, and here it will be more than that. That is what I am saying. See, in this already the 1.4 is multiplied. So this, if the 1.4 is already multiplied here, then you need to see for 1 only. So this should not be more than 1. That's all. That is the condition. So don't go into this. You get confused. Okay, so generally don't go into these calculations. Just see the BCCR. Just see the envelope. That's all. And just try to understand. This concept. That's all. So what software will do? So software will automatically find the capacity of this joint, and let's suppose in this joint the column is weaker. Okay, then what will do? The software will automatically increase the rebar percentage in this column. So how you can increase the moment carrying capacity of beam or column? So how you can increase? Either you can increase the dimension, maybe breadth or depth, or you can increase the steel. This is your AST. So these are the two options. If you increase the AST, your moment capacity of your beam or column also will be increased, or if you increase the dimension, it will increase. So software will automatically increase the second option. So if this is failing in BCCR, then software will automatically increase the rebar percentage for this column and this column, and it will design. Still after that, if it is failing, then it will see initially you will get only 0.8 only, 0.8. But if you use the BCCR ratio, this will suddenly increase and it will become 2%. So what software is doing? Software is increasing the rebar in order to pass the BCCR check. Okay, so it will increase up to 6%. Then after increasing more than 6% also, if it is failing, then software will show as overstressed. Then in that time you cannot do anything. You need to increase the dimension only. So you can see that. Delete it. First we will see the percentage, rebar percentage apply. So you can see, just take only one column, take only this column. So what is the percentage? 1.81. So this column can go to the overrides and you can check. So now in this there are some mistakes you can see. Unbraced length, effective. So you can see the effective length factor here, it has exceeded more than 1. So these two values are okay, these two values are okay, but these two values it has exceeded more than 1. So sometimes software will increase your effective length factor. So in that case what you need to do, you need to override it manually. Let's suppose if you go here and go to overrides, you can see the effective length for your major and minor, it is increasing. So what you can do, you need to change this value. What I will do, I will just select all the column, go to design, concrete frame, overrides, and these two values I will make 1 only. So I have changed it. Now I'll just go and start the design. So now initially what the rebar percentage 1.383 percentage, what I have seen, it is wrong. Now what I'm going to see, that is only correct. Just go to design, concrete frame, display design, rebar percentage. Now you can see. Now how much is the percentage? 1.81. And if I go to the overrides, so overrides also everything is okay. Now in this I have given the B by C ratio. So now I am going to off this B by C ratio, and I am going to check what is the percentage. So what I will do, I will just select all the columns and I will off it. So make it undeform, go to design, concrete frame, and preference. So in the preference I will make it as no and okay. So I need to off for the beams also. Okay, so this B by C ratio is applicable for both your beams and columns. So I'll just off it altogether. B by C, no. Click on OK, then start the design.
This is for ordinary design. So if we off,
Yes, this is for your ordinary design. Yes. So now what has happened? So with your B by C ratio, your requirement of steel is 1.83 percentage, and without B by C, the demand is how much? 1.5 percentage. So actually in that column the demand is 1.5 percentage only, but due to this condition the software has automatically increased the rebar. So this condition should we do? Do we need to do this check? The answer is yes. You need to do this check if your building is in zone 3, 4 and 5. Okay. So now if you want to understand BCCR, no need to go into too much depth into the Excel sheet. No need to go too much depth into the summary sheet. Just you can see from here only. Here only you can find the difference. So this column is failing in BCCR, so the software has automatically increased the rebar percentage. That's all. Okay, so any doubt in BCCR?
Sir, on the top floor.
Yes, I will come to that. Yes.
Okay.
Okay, so this BCCR you can perform for all the columns, but there are some exceptions. So what are those exceptions? Yes, you can see. So this also we have taken from the code only, IS 13920. Okay, so the beam column capacity ratio is determined for a beam column joint only when the following conditions are met. Okay, so the frame has to be ductile moment resisting. If you are designing for a ductile, then only you can check the BCCR ratio. Then a column of concrete material exists above the beam column joint. So if you want to check the BCCR, you need to have, so this is your joint. Okay, so BCCR means always you are checking for that joint only. Okay, yes, so you need to have column above also, column below also, then only you can perform this check. Okay, so when the above column will not come at your terrace floor. Okay, so at your terrace floor the columns will not be present. So for the terrace columns you should not do the BCCR ratio. So even though if code is saying that for all the buildings zone 3, 4 and 5 you should not do the BCCR. So this is also your code only 3920. So BCCR ratio check will not be applicable for your terrace columns. Then what is the next thing? All of your beams framing into column or concrete. So in this joint all the members should be concrete, then only you can do this check. If one steel beam is coming and attaching to this column, then in that case this will not be valid, because generally steel will have more moment carrying capacity than your concrete. So all the members should be made up of concrete, then only you can do this check. Then what? The connecting members design results are available. So that means at this joint all the members should pass. Okay, so at this junction all the members should be passing, it should not fail, because if it is failing then that section itself is not correct. So with that you cannot analyze and you cannot find. So at that joint whatever the beams and columns are there, all the members should be passing, then the load combination should be seismic. Any doubt? So these are some exemptions for your beam column capacity ratio. So the name is same, strong column, weak beam requirement, BCCR ratio, everything is same. Is any doubt in this? Okay, so we have seen BCCR. So in BCCR it is not only applicable for your flexure. You can see BCCR has to be done for flexure as well as for your shear also. So we have seen only the flexure, so that is we have seen only the bending capacity of that particular joint. That is what we have seen. So likewise you need to find the BCCR for the shear also. Okay, so that they have given in this sheet. Just go to joint shear. Okay, so again in this no need to go in depth about this, just if you understand the concept it is enough. So we will go into the document. Okay, so I will open the code. This is an old code, you can refer the new code. Okay, so you need to find the joint shear. So to find the joint shear, first you need to understand, so this is your beams and frame. So let's suppose your frame is swaying. So the frame is swaying like this. Then in that case your shear force drawing will be different. So how it will become? So it will be like this. Just delete. So lateral force is coming from here, so the frame is also swaying in this direction, so your shear force will be like this. Okay, so let's suppose if in the same frame lateral force is coming from this side and frame is swaying from right to left, then your shear force is going to be like this. So there are two conditions: sway left to right and right to left. So in both the cases your shear force value is going to be, see, in this joint you cannot take only this as a maximum shear, because in the other direction this will be maximum. Okay, so that is what you need to understand. So what basically, based upon your swaying condition, your shear force value and the direction will change. Okay, so based on that there is the formula. So for sway to right, then for sway to left. So in this you can see the shear force 1.4 times, and you need to take the moment of that particular joint. Okay, so if you are finding the joint shear for here, so at this joint you will be having the moments here and here. So this will be your negative moment. Then here you will be having your positive moment. So you need to, at this joint you need to take this negative also, positive also, and from this joint also you need to take. Okay, so based on the moments and divided by this length, so there is some formula. So based on that, this should be, this DC ratio, it should be less than 1. That is the main thing. Now no need to calculate these things. So just now again we will go into here, joint shear. Okay, we will go to the result. Yes. Okay, so this is your formula. So V is equal to 1.4 times MUBL. Okay, so based on the shear force as well as the moment, the checking will be done, and this ratio, it should be greater than 1. That's all. If it is less than 1, then software will not increase the rebar. Okay, for the shear, if the ratio is less than 1, then the software will automatically indicate that it is failing. You can see the calculation formulas. Yes, this is the drawing. Okay, so in this also, ultimately what it is happening at this, see, ultimately at this joint your shear capacity should be more. Shear capacity should be greater than shear force. Shear force from beams on all sides. That is the main thing. So ultimately at that joint your shear capacity should be greater than the shear force coming from this beam, and in the other two directions also. From the column you leave it, because generally column shear force will be less. Only your beams, your shear force is going to be more. So what is joint shear? Joint shear means at that particular joint the shear capacity should be more than all the beams which is framing out of that joint. Okay, yes. So if this is failing, then software will indicate that it is failing in joint shear. Software will it will not increase the rebar. Okay, so that is your joint shear. Any doubt in the joint shear? So yeah, here you can see. Yes, so if you go to the envelope, here you can find the ultimate results. Joint shear check. So here you can find at that joint The maximum capacity is how much? 755 kilonewton in the major direction, and in the minor direction the capacity is how much? 434 kilonewton. But due to the beams, how much is the shear force? 183 and 175. So just if you divide this, you will get this ratio. So DC, what is the DC ratio? DC ratio is 0.24. It is less than 1. So it is passing in joint shear. So for the joint shear also, no need to go into everything. Just go into the envelope and see this table, and this DC ratio, it should be less than 1. That's all. Any doubt in the joint shear? Yes, any doubt? Do you have any doubt in the joint shear? Today we have completed flexure, shear, joint shear, BC shear, and envelope also. So envelope means from all the sheets, what are the things that is important that will be given in your envelope.
Maximum value it will take for design.
Maximum value of
All the moments for design it will take.
maximum value, how it will depend? It depends upon the section only.
Section.
There is no limit for maximum. See, generally whenever you are designing, you will not go into this much depth. Just you will see what is the rebar percentage, 1.49. So find the steel, detail it, that's all. If this column is having steel, maybe 5%, 4%, 6%, or it is failing, then in that case you need to go, and in that case you need to investigate whether this is failing in moment or it is in shear, whether it is failing in BC shear or it is failing in the normal one. So which moment is governing, M2 moment or M3 moment? So what can you do? Can it is due to the slenderness effect or not? Can you increase the column size or not? Or can you increase the steel? So those things you need to find. So that how you learn by doing projects, by solving the projects, by designing and solving it, you will learn those concepts. Okay, so for today it is enough. Tomorrow again we will take the same thing. We will just keep the revision of this column design. Then beam, see, once you understand the column design, beam design is simple. Just it will take 5-10 minutes for the beam design. So the column design is the difficult. Okay, so tomorrow again we will have a revision for the column design. Then we will finish the beam design also. Okay, so today you can practice and you can ask the doubts. So for practicing also, I said just go to this help and documentation. See, whatever I said, it is from this document only. Just go to concrete frame and go to Indian code display. So how much is 80 pages? So in the 80 pages you will not require everything. So just start from the design. Yes, just start from here. 3.2. Just read all the thing. You will understand. Okay, so for today you can read this document and you can ask the doubts from this also.
Sir, can you give me a small definition about slenderness?
अर्निंग चाहिए तो लर्निंग करनी पड़ेगी, ज्यादा अर्निंग चाहिए तो ज्यादा लर्निंग करनी पड़ेगी, और लर्निंग के लिए ई कंस्ट्रक्ट मास्टर स्टडी ऑन जॉब प्रोग्राम्स है ना। अगर आप सिविल इंजीनियर है और अगर आपको कोर टेक्निकल प्लेसमेंट चाहिए सिविल इंडस्ट्री में, तो ई कंस्ट्रक्ट के ऑन जॉब फुल टाइम ऑनलाइन और ऑफलाइन ट्रेनिंग प्रोग्राम्स को ज्वाइन करके आप सिविल इंडस्ट्री में अपना पहला कदम रख सकते हैं। तो आज ही ज्वाइन कीजिए मास्टर स्टडी लर्निंग प्रोग्राम्स एट ई कंस्ट्रक्ट।